Okay, so for our frame, we decided to make it out of chromoly. And as we were making it, we had like a rough design concept, and that was continually changing. And so we ended up making this PVC pipe mock-up frame that you can see in the center, and it's built to scale. And we modeled the roll bar around our main driver, Samantha's head and shoulders and everything to make sure it would work. And then we measured and took the exact measurements of everything before putting those into a detailed drawing. As for the suspension, we began our design with a traditional double wishbone suspension and ended up changing it on the suggestion of one of our members who is highly interested in Formula One racing, and he actually gets to discuss our new suspension at great length later in this video, so I'm going to leave that to him. And our steering also started in the traditional rack and pinion style, but we ended up changing it to a Pitman arm, which again will be discussed in the unique aspects of our car section of this video.
For the solar panels, we are going to put them together with the individual solar cells with the SunPower EV3 cells, and we would, by the process of soldering them, and then you tab them together in a 3x9 formation, and then you laminate using gloss-free lamination, and then you would put the glass on top, and then EVA film in between for protection of the panel, and then on the bottom would be the TPT or Tedlar composite as the base layer.
So now the electrical system. First, our team has debated between whether we should use the lithium polymer or the lithium ion batteries. Lithium polymer batteries are generally smaller. They have higher specific energy, but they cost 10 to 30% more than lithium ion batteries. But on the other hand, lithium ion batteries, they have a better energy to weight ratio, and they are cheaper than lithium polymer batteries. So at the very end, we had decided to go for the Panasonic 18650 lithium ion batteries. And next, our team debated between whether we should use the 96 volt or the 72 volt system. The 72 volt system has a lower electric current and electric potential, but it is capable of running for a longer period of time. So that's what we ended up using. And next, the main battery configuration. Each individual battery is 3.6 volts. And since we decided to make the car run on a 72 volt system, we wired 20 individual batteries into a series. And then we wired multiple series of 20 in parallel.
For the shell construction, we started with designing a 3D model using Fusion 360. We did it based on the measurements of the 3D frame model we created earlier, and our goal was to make it as aerodynamic as possible. Material-wise, we chose fiberglass for its lightweight. And as we began to construct the shell, we cut it out wood to make the form as the mold for the fiberglass, and then we were making a styrofoam model inlaid with the wooden supports. But unfortunately, we were not able to finish it due to the COVID situation earlier this year.
Last year, our team was set up into 7 different sub-teams, which were the frame team, the electrical team, the steering and braking team, the suspension team, the shell team, the panels team, and the programming team who work with the PyTop technology. Each team had their own captain, their one captain. One team had 2, the frame team. They were either senior, most of them were seniors, but a few were juniors, and they controlled the operation, but everyone worked as a team, and it was not just one person controlling everybody.
This year, we are all working as one big team, but we are going to rotate around different aspects of the car so we can always be working on something. For the shop, we are split into 2 equal groups of 4 per COVID protocol.
There are two unique aspects that we have to point out. First is the new suspension system. The system is inspired by Formula One race cars. There are three main benefits. First, the system is lightweight. We're using one shock instead of two, so we can save a lot of weight there. And second, the system benefits the general aerodynamics of the car. We no longer have shocks hanging onto the sides, exposing to the airflow. So it benefits the general aerodynamics. And third, this suspension system really opens up a lot of tuning capabilities, so we can fully tune the suspension system to fit the circuit. And second unique aspect is that we're using a Pitman steering system instead of a rack and pinion system. A Pitman steering system will reduce the steering input while it's also lightweight, so the driver can have a more sensitive or responsive car on the circuit. However, while being more sensitive on the steering, it is also easier for the driver to oversteer the car. So the driver has to have a very precise steering skills. That's kind of a downside of it. And this Pitman steering system, it is hard on tuning.
Our process. First, we drew our frame with the CAD design software on Fusion 360, and then we attached PVC pipes together to model our frame before we actually melt and work on the frame. And then we use the PVC model as an example and a guide for where certain aspects of the car would go. And then we bench tested the electrical system and it went well, it worked. And then we assembled and 3D printed the battery boxes. After that, we started to work for soldering and laminating individual solar cells, and then COVID hit, and we had to stop our work.
Hello, my name is Noah Inlow, and I'm the newest addition to the All Saints Solar Car team. I joined the team because I enjoy engineering, and the Solar Car team is the best engineering team on our campus. I have taken on smaller engineering challenges before, but they're nothing compared to actually designing and building a vehicle that runs off of solar energy. Another reason that I joined Solar Car was to be around people that have the same interests and work ethic as myself. I'm very excited that I was accepted, and I'm looking forward to this year.